Hi, thank you for watching the next installment of my organic chemistry series. Today I'm going to be talking about Markovnikov addition and anti-Markovnikov addition using halides and alcohols. So let's go to the marker board. Basically, Markovnikov additions make the major product which is more stable. So we're going to use an unsymmetrical alkene for this. The most simple one is propene. So CH3. And we're going to be adding hydrogen bromide to it. And basically the bromide can have a nucleophilic attack here at the first carbon or the second carbon, forming either a primary or a secondary carbocation. Now you're going to find that the primary carbocations are less stable than the secondary carbocations, which are less stable than tertiary carbocations. So therefore the predominant product is going to be 2-bromopropane, which CH3, CH, bromine, CH3. And you're going to have a negligible amount of 1-bromopropane, which is produced from the reaction. Now, if you look at this, the 2-bromopropane is simply more symmetrical than this 1-bromopropane. The bromine here is on the edge, it can be knocked off. It looks unsymmetrical, very unharmonic, or not harmonic. If you look at it on the test, just count the number of carbons and see what looks more stable logically to you. Now, if we do it on a larger scale, the heptane, look at CH3. Now I can form a carbocation on carbon 3 and carbon 4. Now if you look at this, if the bromine that I'm adding, HBr, attaches itself to carbon 3, I'll have an ethene group over here, and I'll have a 4-molecule butane group over here. So it's less stable, whereas if I go into carbon 4, I actually have a perfectly symmetrical molecule that looks like this. So obviously your majority of the product is going to be this more symmetrical molecule. It's just more balanced and therefore more stable. But in the presence of peroxides, this is where you're going to have an anti-Markovnikov addition, where basically the opposite is true. The less stable molecule is the predominant product, and the more stable molecule is more of like a negligible byproduct. So we're going to designate peroxides with ROOR. We talked about peroxides, I believe, in chemistry video 6. That was the last one. So if we do the same reaction, CH3, CH double bond CH3, and we add hydrogen bromide, the predominant product is going to be 1-bromopropane. This also holds true with the creation of alcohols from alkenes. Let's do the same thing when making alcohol with propene. To add water, I'm going to use an acid, H3O. And from this, we're always going to form secondary alcohols at least, because the same holds true. The primary alcohols are less stable, the secondary alcohols less stable than tertiary alcohols. The only time that we'll ever form a primary alcohol is in the case of ethene. where we don't have a choice but to form a primary alcohol. You know, whether it attacks this carbocation or this carbocation, it's still going to be a primary alcohol. Whereas here, we're always going to form a secondary alcohol in the case of propene. So we're going to have CH3, CH hydroxyl group, CH3. So, and in other larger molecules, we're always going to form tertiary alcohols. The example here. This is isopropyl propane. Here we're always going to form a tertiary alcohol. In the case of Markovnikov addition, always this carbocation is going to be a lot more stable. I'm sorry, I need to have an alkene. Apologize for that. So anyway, we're always going to form this carbocation, not this carbocation. We're not going to form a primary alcohol here. So we're always going to have the majority product of this. We're never going to have this. This is going to always be negligible and, you know, maybe not even exist or never be formed. So if you have any questions about which molecules are more symmetrical, or like why Markovnikov addition would apply, or which one is more stable, just basically look at the structure logically and try to see which one is more symmetric, which one would yield the more stable molecule. So if you have any questions or comments, please email me, and thanks for watching.